recording, and we're trying to get MinGW as a Windows package. Those of you who have Macs or Linux machines don't need to do anything. It comes with the compiler pre-installed, right? It is true that there are other versions of C, for example, Visual C++ for Windows, all right? And most of the code that we will be using, if you take it and run it in Visual C++, it will run fine, right? You will, however, miss certain aspects of using C that I would like to emphasize. Most specifically, the fact that we have to run a compiler, produce a binary, and run the binary. And the other aspect being that we have to link in libraries, and we have to look for libraries explicitly, right? It's a much more manual process as compared to the Python pip, right? So pip was very nicely automated. I would just do pip package gets installed, everything runs fine, right? Here we're going to have to manually download a library, put it in a folder that is convenient for us, and pass in a command line option to specify that that library needs to be linked in. And when you're going to see this, you're going to understand a bit more about what's happening in a real programming language, because all those things actually are happening under the hood in Python as well, right? And it's convenient to have them hidden from you, but that also takes away a level of understanding about computers and operating systems. So I would like to take advantage of the fact that we're here to just showcase that. So first piece of code, and you might have heard of the fact of the Hello World program in multiple programming languages. And many classes start with a piece of code that writes Hello World, right? And I think we started with that in Python when we did that. And guess where this habit of writing a Hello World program originated? It originated with C. C is one of the oldest programming languages. It appeared in 1969, 1970. It had a very stable version in 1972, and it was created as a portable assembly language, right? And if you don't know what assembly language is, I'm not going to tell you. You can go ahead and Google it, but you don't need to know. The attempt was at that point to write a portable operating system, an operating system that would run on multiple machines of different architectures, right? C did not solve completely the problem. C solved about 90% of the problem at the time, but that was still a huge enhancement compared to what was there before, because now you could take this 90% of the operating system, add a specific 10% on each machine, and then each machine could have the same operating system that became portable. This operating system was called Unix. You probably heard of it, right? And Unix, because it unified machines with a single operating system, it unified architectures. And it is the great grandfather of Linux and Mac OS, right? So both Linux and Mac OS are Unix-based operating systems, right? The first free version of the compiler was this GCC that we're using now. It appeared in the early 80s. It started, people started to work on it. The need for a free compiler was very apparent. The person who initiated the GCC was Richard Stallman. So, and this is quite a character. You see when I type Richard, immediately the first suggestion is Stallman. So here's quite a character, all right. And he's the guy who created this GNU Foundation, All right, you may read about it. There are many stories to tell. So, and he's the guy who is very well known for somewhere it's known for, right? Known for. So GCC, you see it here, right? And also the editor Emacs, right? So he created the first integrated development environment, the first IDE for C, and it was called Emacs. Not just for C, but the main purpose was to write C code to enhance the operating system. All right, so let's go back to um, the um, the first C program, and I'm going to write the simplest form, and then I'm going to add to this. We might get a few warnings out of this. So notice the semicolon. I remember somebody remarked in Python, why don't we terminate lines with semicolon? And I said at that point that we don't do that in Python. Well, we do that in C. All right, I'm going to save this. In our code C, and we're going to call it hello. Okay, so now we want to run this program, right? So we're going to do two steps. The first step is going to be compiling it. All right, and we get a warning, and bear with me, we're going to explain the warning and get rid of it. All right, and what is the result of this? Okay, you see here a file called hello. And if you look carefully at the attributes of this file, all right, you notice that it's an executable file. All right, it has these X's. There's an X here. This is the most important X. The owner can execute. Right, this X means that yes. What a pain. How much is it missing? Okay. Another thing we could do is make this a bit bigger. Okay, is this better? Cool. So the highlighted X says that the file is executable, right? And now I'm going to execute the file. And you see the output hello world, right? So before looking at a program, let's look at the process of making it run. We have compiled first, and then we have executed the file, right? So this is a process that actually happens in every programming language, right? Python would do the same, would first compile and then execute. However, right, since it's not so difficult to figure out whether a file has been compiled or not, Python does this automatically. Checks is my source file compiled? If no, let me compile it first and then execute it. Right? It's not a difficult thing. But historically, right, in the old days of C, that was too much effort for a machine that would have very little computing power. Right? So people would rely on their own knowledge, so they would compile first and then execute. And then compilation happens once, and execution would typically happen multiple times, right? I compile the code, I give you the binary, so this is what we call a binary. I give you the binary, and then you can use the binary multiple times, right? Any of the commands that we typically run on a machine, for instance, right, I'm typing this command ls, right? So let's look at the attributes of the command itself, right? So this is a binary. It's exactly in the same fashion, right? We're using ls very frequently. We are not compiling ls. Somebody has compiled it for us, right, before selling us the computer, right? And now we're using the computer and the program ls. We are using it in the binary form, in the compiled form, right? So compilation typically happens once, execution happens many times, right? Is that understood? So it's important to understand this process, and it's important to understand what happens at compile time and what happens at execution time, because since compilation happens only once, we can afford to have expensive things, computation expensive things happening at compile time. We typically cannot have computation expensive things happening at execution time. All right? So if we can spend a little bit more time in the compiling phase to optimize the binary so that it runs faster, that's worth it, right? Because the binary will be executed many times. The compilation will happen only once. Okay? Cool. So we had some warnings. All right? So it says here type specifier missing defaults to int. All right? So one way to get rid of this will be to use this warning suppression option. Right? I'm not saying that this is the good option, the good thing to do, but one thing we can do, all right, is to do that. So if I run this command and I add this, is it no? Yes. Okay. So I put a no in front of it. I'm a bit rusty. I get rid of it, right? There are valid situations where we need to write code in a certain way that will generate warnings, and nevertheless, that's the right thing to do, right? And I also told you before in the Python course, with great power comes great responsibility. Python C is an extremely powerful language, right? It allows a lot of flexibility. It allows a lot of access to hardware and operating system, right? And because of that, the system always tries to warn us when it thinks that we're doing something potentially wrong. But oftentimes, we are doing something that is unorthodox. But it is the one thing, the thing that we want to do, because that's the type of interaction that we want to have with the operating system, right? It's not a very typical way of using C, but then, so the system is trying to do its best to warn us. And one good practice is that you should never have warnings coming out of your program. If you give your source to somebody else and they compile it and they see warnings, then they can't trust your program anymore, right? So in principle, you either suppress your warnings explicitly, like we have done now, or you correct your program, right, to get rid of the warning. In this case, we can put an int here, and that will save us. Okay. And now I can go back to the previous command, perform the compilation, and there's no warning. Okay, let's try to analyze this program a little bit. So C is actually a combination of languages. It's not just one language. So, or what we're using typically is a combination of languages. There is this part called the macro language. There's a macro language. And that is processed by a macro preprocessor, which is called CPP, and which you can invoke manually. And now it's expecting stuff from the input, and it will let's see if I do. So that will make it a bit easier to explain. Okay. So what happens is that this file is first processed by this processor, right? It's first processed by this processor. This processor will include another file, will take another file and paste it in, right? We don't want to read this file. This is a too complicated file, but this is pretty much what's happening, right? It becomes, a C program becomes a pasting of multiple files. And then it continues on with this. Once it produces this pasting, which is a relatively large file, then it invokes the compiler. Okay? We'll learn later why we need this. We're going to see that we need prototype for functions, and this stdio.h has a prototype for printf. stdio stands for standard input output, and pretty much anytime we need to do an input on an output, right, we're going to add this line. All right. What else is there? So C is a combination of functions, right? The program is made out of functions. This is one of them, and we can have many. Actually, we can have a lot. And these functions, they're called functions. They're not really functions. They're procedures, because we discussed in Python with some of you that a function always returns the same result for the same argument. But that's, as we'll see, is not the case for C. But we call them functions. That's how the creators of C have called them. And there's one function that is singled out, and it's called main. And that function is invoked first by the operating system. We can think of whenever we type hello here, we're essentially invoking this main. And this main function can invoke other functions if we have them, right? And then inside, what happens is that we execute line by line. Printf is a library function. Where does it come from? It comes from what we call the standard library. And a part of that standard library is the standard input-output library, right, which we have included here. Printf stands for print formatted. All right, and we're not formatting anything here, but we're going to see pretty soon how we format things. This is what you see inside a string, which looks like pretty much like a Python string, right? Just that the printf function does not add a new line to its printing. So we have to do it explicitly via a control character. So \n is the control character that tells the printing cursor to go to the new line, right? So notice, as we run this, that there's a new line between here and here, right? If I select that, there's a new line between these, all right? So let's see what happens if we don't have this. So we're going to compile. And, well, this is a Mac. So the Mac doesn't like the lack of new line. So it will tell me, it will force a new line here. But with this % tells me that there's no natural new line between the exclamation mark and the square bracket. Normally, in other in other terminals, and actually I have another terminal. So let me see if that will happen there as well. The same thing. Okay, let's do a different thing to understand the difference. Okay, so let's say we write hello world twice. And then I'm going to put a \n here first. And let's see what happens. Okay, so you see that between this exclamation mark and this H, there is a new line. They appear on two separate lines. If I remove this, okay, the new line is not there anymore. Okay? All right, let's move on to a more sophisticated program. Let's try to print the greatest common divisor of two positive numbers. Okay, so new file. Okay, and we're going to see more stuff. So for the time being, let's just declare two variables, and I'm going to make them 144 equals some other interesting number. 81. Okay, and how do we find the greatest common divisor? So I have to put a condition here, right? So while, anybody? No, I mean, we could say true, right? But b greater than 0, okay? So we're going to assume always that a is greater than b for the time being, okay? So if so while b is greater than 0, what I'm going to do is int tmp is equal a percent b, right? Then tmp is definitely greater than tmp is definitely less than b, right? So we're going to do a is b and b is tmp. Okay. So at some point, b becomes 0, and that's when we have the greatest common divisor, right? And we're going to say GCD equals, and we're going to do a percent %d here, backslash n, and we're going to say a. Okay? And let's save this as gcd.c. So compile. Okay. And we're going to get that GCD is equal to 9. Okay. So let's start enhancing this program a little bit. All right. So what would be a nice thing to have? First of all, we would like to read the two numbers from outside of the program, not hardwire them, right? So this is what we call hardwiring the program. So we have two ways of doing that. Okay, but before that, let's look a little bit at the code, right? Because there's new elements being introduced here. So you are familiar with the concept of a variable, right? You've seen that in Python or in other languages, and notice that we need to add a type, and we're going to look at data types in more detail later, right? You remember from Python that we have multiple data types. We have int, we have boolean, we have string, right? And then in Python, we also had aggregates, lists of things, tuples of things. We don't have that in C anymore, right? And the question is going to be, how do we replace those? But that's later. Notice that we have to use the type. And the only type that we learned so far is int. It's an integer type. And I'm going to harp on it a lot. So we're going to figure out what would this type int first. It might look simple, but it's not quite. But for the time being, let's just keep going. Then we have a while loop. So this should be reasonably familiar. Notice that unlike Python, in C we need these brackets. So now you might find the explanation of why I was typing brackets around in while loops so frequently. Well, because some languages have them. Right? B greater than 0, right? And you're going to think that it's a Boolean, but actually it's not. It's an integer. It evaluates to 1. All right, b greater than 0 evaluates to 1 if b is greater than 0 and to 0 if not. And what we put here is a integer in general in the while loop. And the while loop keeps executing as long as the result is non-zero. It stops when it's 0. So, for all intents and purposes, I could have written while b. All right? This is generally not recommended because people now write code in many languages and they have to remember all these weird rules, right? And writing code like this is a lot more explicit. But I could have written while b. We're going to create a new variable, and notice that again we have to provide a type. We produce a calculation. This is exactly as in Python, right? A%b is a reminder, the reminder of a divided by b. And then these are assignments, nothing new here, right? We close the while and notice that the body of the while needs braces, unlike Python, which only needs indentation. We can be nice and indent if we want, but if I write my code like this, no problem. If I write it like this, no problem, right? The body of the while is going to be from this brace up to this brace. The spacing doesn't matter, right? The spacing is just for the human reader, not for the compiler. And when b reaches the value 0, we print. When we print, now we understand the meaning of formatted printing. Okay? We have this format specifier, %d, that appears inside a string. And this is just a string. It's nothing but a string, right? But when you give it as a first argument to printf, printf will parse this string, will look for format specifiers like this, and then we'll take the remaining arguments from printf and format those and replace them inside the string. Okay? So what was going to be printed? GCD equals, and then this part of the string will be printed out, and then printf will go and say, oh, this is a %d. So let me go outside in the remaining arguments, take the first one, format it according to this guy, and print it out. %d means integer, and then you're going to say, why not %i? Because int starts with I, and right, historically, this is how it works. Okay, so that's a historical thing. This is how printf has always been. Okay, and then the program ends. So this is formatted output. Now there are other interesting formats. For instance, %x. All right. And I'm going to change the numbers because it's going to print 9 as well. So let me get something like 512. See whether that's going to be better. So the GCD now should be what? 144 and 512. What should we get? A has to be bigger than B, right? So agreed with you. So 5, 1, 12, and 1, 4, 4. Okay, let's see. Let's see first what the result is, and then use the X. Yes. Okay. Very good. 16. So 16, right? So now, if I put X here, what's the output going to be? Anybody knows? Right? What do you think the X means? Okay, let's do another experiment. So, and I'm going to put %x several times. How many? 4, 6, 8, 10. And let's put some random numbers, but in increasing order. Two, 4, 6, 7. So 16. All right. So I'm going to comment this one out, and now we learn how to comment stuff out. I forgot a comma here, yes. What are these? Nobody knows. Yes, louder. So, normally how many digits do we use? How many digits do we use normally? They're called digits, right? So this in Latin, these are the digits, right? And as they came into English, right? They are 10 because each digit as a number represents one finger, which is a digit in Latin. All right. So we use 10 digits, but could we use a different number of digits? Yeah. So somebody said base 16. So have you heard of base 16? So we could use, for instance, 16 symbols, right? And we get a numeration system called hexadecimal, right? Base 16. So what happens, right? We start counting, and we reach number 9. We start at 0, we reach number 9. But we haven't exhausted our digits. We have 16 digits. And how are we going to call the remaining 6 digits? A through F, right? A, B, C, D, E, F. So we have the digits from 0 to 9. And then A is 10, B is 11, C is 12, and so on, right? D is 13, E is 14, F is 15. Okay? So this is why we want formatting, because percentage D is decimal, actually, and now the D makes sense. And percentage X means hexadecimal, which, yes, that will be binary. So that was my next. Very good, very good. I think it's command R, right? So I want %X. What do you see to replace? No, maybe it's but why can't I find it? Oh, find. Okay. Yeah, Command Shift S. Okay, so I want %x and I want to replace it by %b and replace all. Oh, invalid. Have things changed since I last coded in C? Oh, maybe it's not standard. I'm pretty sure it was B. Maybe it's capital B. No, not. Uh-huh. Okay, let's leave it. Maybe it's not. Maybe it's not standard, and then this particular one doesn't have it. I remember using it for sure. Octal. Because it should appear as binary under binary. Yeah, definitely. Okay, let's not waste time. I'll figure it out and tell you later. Okay, so uh, all right. So we can use various format specifiers. All right. There are certain quirks to it, but I'm not gonna show them to you now. I'm gonna do that um, later. So let's leave it to D, and then what if I want to print a backslash? All right. So this works like in Python. We can just use double backslash, right? And no need to try. All right. There's a different thing that I want to do here. So first of all, um, what happens if we want to have the numbers in any order? What would be nice to happen? Louder? Sort them. Very good. Right? So we could do something along the lines of, and should I introduce a function here? All right, let's try to use min and max. So I'm going to say int a min, which is equal a max, to be max of a and b, and int a b min, which would be min of a and b, right? And then here we're going to use b min, a max, b min, a max, b min, and then we're returning a max. Okay, so now we're no longer in danger. The question is, where are min and max going to come from? And let's see if stdio has them, right? And actually we see that they are not. So we have to find a way to a place where we can get these. And if I remember correctly, this is math.h. The .h stands for header. And these are actually files that you can check. All right, I'm going to show stdio to you. So I think it's usr. Is it include? No. Start lib include. Okay, it's somewhere. Usually it should be in usr slash include, but that doesn't seem to exist here. You can see there was one here, a usr include. So it would be interesting if this one has them. C++, v1, std. I have no idea where they may be. They're somewhere in there. Okay, forget it. Sorry. I think things have changed quite a bit since I. All right, let's try the math.h and see if that works. Right? Those are just files. That's what you need to try to remember. I forgot the. And still we didn't find them. All right, I'm going to try a different one called stdlib.h. Seriously. Okay, c min max stdlib. Pretty sure. TCC. So it seems they were removed from stdlib. Should be in stdlib.h. If I add the math library, LM, there's no min and max in C. That's a very strange finding. All right. All right, let's implement min and max. With this, so this is how we find out, how we learn how to implement functions. Int min, int a, int b, return a less than b, question mark, a, colon, b. Does everyone know what this means? Greater than b, question mark, a, colon, b. All right, so from this, I pretty much am telling you what this expression means, right? So we evaluate this Boolean condition. If it is true, we return the first result. Otherwise, we return the second one. Okay? So now that we have min and max, I'm going to remove this standard lib. All right, and let's try again. No need for the math library. So we can run gcd, right, and we get a result. Okay, so now it's going to be interesting to read the numbers from the command line. All right, so to read them from outside of the program. So let's do this in, we can do it in two ways, and I'm going to show you both of them. So I'm going to define two variables as placeholders, right? And then I'm going to use the following functions: scanf, scan formatted, and I want to read two numbers, and these numbers should be integers. So %d, %d, okay? And I'm going to do a trick that is going to be very tough to explain. Ampersand a and ampersand b, and it's going to take a while to explain what the ampersand is. Okay? So I'm not going to do it immediately. I'm going to show you two ways of doing it. So now when I run the program, you can see that the program stops and waits. And I can input two numbers, 250 and 1025. And I'm going to get the result there. Okay? Again? So what happens here is that we have these two numbers that have been input from the keyboard have been placed into the variables A and B, right? The first number, the first %D, so this is read in, right? Because of this specifier, the first sequence of characters will be converted into an integer and placed into A. And the second sequence of digits will be placed into B. The space here is taken as any number of white space characters, right? So between these two, we can have a space right here, right? Yep. You can't. So everything that you have here has to be read. So if I say A equals and B equals, where there? Where? Not sure what you mean. No. 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 All right. Um, all right. So this is one way. Okay. The perhaps more elegant way is to read them from the command line. So I could write something along the lines GCD 1000 and okay, I could do this. Okay, so let's learn how to do that and get the result, right? So before doing anything else, so I'm going to add arguments to main, and the arguments are going to be let's write it in this way. Perhaps it's okay. So for the time being, we've put types, right? We're learning a new type. We're going to see that very soon that we have a type called character. And character is actually just some weird type of integer. It's not really a character in the actual sense, right? And then when I put this star, for the time being, this is a string. We're going to learn more about that star. And because I have put an square brackets here, this is an array. So we have an array of strings. What happens is that whenever we type more stuff on the command line, right, these things that are on the command line are separated by spaces, are words separated by space. Each word is a string and will be placed into an element of this array. This number is going to tell me how many words there are, including this one. That makes it a bit tricky. Including that one, right? So in this case, this guy is going to be equal to 3. And inside here, we're going to have 3 strings. All right? So these numbers are coming in. All right, and I pretty much want the same string, the same story. But instead of reading from the keyboard, I want to read from memory. So I'm going to use a different function called scanf, which reads from a buffer. All right, and because we have two separate arrays, two separate words, the first one is going to be argv of 1. So this is the first element of the array. And then I'm going to do the same thing, argv2, and I'm going to read that into B. Okay? So we compile now, and we get the result. Okay? And now notice that what we've done is the first number is smaller than the second one. All right? So our little trick of sorting the numbers worked as well. Okay? Yes? So for the time being, think of it as a string. Right? And the way C works is that you start from the inside out. You start from the symbol, right? And the closest to it is the array, right? So it's an array of strings. So it's an array of strings, right? So the operating system will do the parsing for you, right? We'll break this line, right? We'll break this line into words. We'll break it on the spaces, and all the words will become strings and will be placed in an array. Unlike Python, where I could say len of array, in C we do not know the length of an array. The array does not implicitly contain its length. It's very low level. So the length of an array, the size of an array, always needs to be communicated separately. You have to store it into an integer and make sure that you pass that integer separately. Okay? So, this is probably the best place to stop for today. So that was the one thing that I wanted to show indeed. So let's see what happens. The parsing will fail, right? So let's say I input arbitrary strings, right? The parsing will fail. Because of that, it will stay with the value that it had originally, right? And you're going to get a value. So we should try to guard against that, right? Quickly, how do we do that? So you're asking, can I say A equals scanf? And I'll explain now why. So I can say here int count equals, right? So the result of scanf will tell me how many of the specifiers were successfully read. Right, so we have a single specifier and we're expecting a result of 1 here, right? And I'm going to go on and say count plus equal scanf, right? So if everything went on correctly, I should have a count of 2. If I have a count that is less than 2, something went wrong, right? So we can say now if count less than 2, return 1. So why do we do that? So besides returning 1, we should actually print a message, and I could just print F, right? But I can't remember which one is for printing to standard error. Okay, let's just use printf. Right, incorrect arguments, \n, and we return 1. And you're going to wonder, why do we return 1? And how come we don't return anything here, right? So if we were to return something, we would return 0, right? So that would be the default value in case we don't return anything. So if we run this program, right, we get incorrect arguments, right? But there's one more thing that we can do, right? I can define a result, which is a property of bash. I can't leave spaces actually, equals so I have to use these brackets and this string, right? No. I think I don't have to use anything. So for instance, if I do this, I can now evaluate how do I do this? Yeah, so I can get the 1, right, and I can use that in the shell, right? So normally what we do is any non-zero value returned from the main signifies an error. So the operating system knows that it's an error. There's an error code. All right. So not only do we want to print incorrect arguments, right, like we did here, but we also want to tell the operating system that the result was incorrect in general. The other thing where this doesn't work very well is if we use negative numbers, right? -10 and minus 15, for instance, right? So this doesn't work properly. So we should say if count less than 2, or right, a less than 0, or b less than 0, and actually equal to 0 is also a problem, right? So now right, we would get incorrect arguments for this as well. Okay. Now this is a good place to stop, right? So next time I'm going to investigate integers a little bit more. All right. And in this way, look at all the operations that we have on integer and understand why they're useful. Okay, I'm not going to yet explain the need for this and this operator here, right? We're just looking at them as strings. They're not strings, they're pointers. And it's a very scary word for many people who have just cursorily looked at C. And it's generally one thing that is difficult to understand, and I'm going to endeavor to explain it well. But I want to look at data types first and go to the bit level of the data types. Yes? What happens to So they're not wasted. I should remember my bash coding and figure out how to right. So for instance, I can use it in an if statement. So if gcc if, let's see, then yeah, something like that. So oh, okay, this one should be, I think, or this one. All right, so let's try it this way. So at the point where I tried result equals this, I should just say dollar and then echo result. No. No. So let me run it like this, and then echo dollar question mark. Okay. So this is Taha. Hey. So this is it. All right. So you get the GC. You run the command. You get the output, but then you also get the one. Okay. So the one that was being printed returned here, right? Whereas if it runs correctly, so let's find one where we got a correct result, right? We get a 0. Okay. So from outside of the program, the operating system has that information, right? So if we write something like shell scripts, we can actually tell. Okay, I'm going to upload these to the course folder, right? So you can review them and run them on your own. If you have questions, stick around, and